Hello everyone, this is 158335 Assignment 1. My name is Wang Shuo and my student ID is 220000164. This assignment is a system to monitor environmental conditions using Raspberry Pi, SenseHead emulator, and a server and a web application. First, I will show you the high-level architecture. First is the headwire layer. I utilize Raspberry Pi as a project environment. Then is data processing layer. Write the Python scripts to control the SenseHead emulator, read the data from the sensors, and send data to a back-end server for processing. Then is the front-end interface layer. HTML, CSS, and JavaScript are used to build the web interface, which is used to display the temperature and humidity in data in real time, and to get data from the backend server through the Flash API. Then is the backend server layer, using the Flask web framework to collect data from Raspberry Pi sensors and process it. Then I will show you the connection between them. As you can see, the SenseHead emulator simulates temperature and humidity data, and then the Raspberry Pi runs Flask server software to handle requests from the web interface and communicate with the SenseHead emulator. The server sends the data in JSON format to the web interface, which uses the Flash API to send and receive the data and update the content on the website based on the data received. Here, you send the HTTP request and receive the JSON data. Okay, then I'll show you the setup and the configuration. We need to install the SenseHead emulator. Use the Linux Raspberry Pi Linux command. Use this command to install the SenseHead emulator, and then install the Flask. Use the pipe install. Okay, then I'll show you the code. First is Python. As we can see, this part is to import the Flask framework and some necessary modules, Sense emulator, and OS of Python. Then initialize Flask and the SenseHead emulator. Here defines a root temperature. Here using the add-app root decorator in Flask. And here is to fetch the temperature from SenseHead emulator. And here is the list named warnings to store some temperature warnings. And here is the if condition. If the temperature is not in this area, then we'll raise an arrow. And here is another if condition. If temperature greater than 40 degrees, warnings are added to the warning list, and warnings are also displayed on the SenseHead emulator. Here, and the color is red. Here is to return the temperature and warnings as a JSON response, and return an error message. If there is an error, and here the status code will shows 500. And here is similar to the temperature. The root is humidity, and there is variable humidity and list warnings. And there are two if conditions, and here is also to return as a Johnson response. And here is to uh, um, and here is to define the root which serves an HTML document, especially it since the file named HTML email data HTML file from the current working directory. And this is how to connect the HTML to the Python file. And here run the Flask application accessible on any network interface, and the port is 5000. Okay, and then here is the HTML file. And here is the foundational HTML file style, and here is the JavaScript part. Let me see. Here is the function to fetch temperature data from the Flex server. Here is to make a request to temperature root here. And then to parse the Johnson response and update and invoke the update temperature display function. And here use the catch to log and display error if fetch temperature data fails. Here and the web interface will show error loading data, and this one is to clear any previous warnings. And here is another foundation named update temperature display. It's the function to update the temperature display on the web page. And here is to fetch elements by their IDs to display temperature and warnings. There is the ID. And here is to update content of temperature and display with the data received from the sense head emulator. And here, check if there is any warnings in the data and display zone. And color is red and here strong. And here is the same with is similar to fetch temperature data function. And here is similar to the update temperature display function. It's almost the same. And here, this is function after the window has fully loaded. Here involve these two functions, fetch temperature data and fetch humidity data. And here is the function to fetch data every 5 seconds. Okay, the JavaScript part is over, and here is HTML. It's the body part to show the temperature real data, and the warnings, and show the humidity heading, real data, and the humidity warning. Okay, this is the code. Then let us see how it runs. Oh, here. Sorry. Okay, here. And you can see here is the sense head emulator. And we open the web page. And here we'll show the temperature current temperature and current humidity. It's the same with the emulator. The network is slow. Then let you change the temperature. If the temperature greater than 40 degrees, and here is the warning, and then there is the warning to high temperature, and it shows the same temperature. And if we change the temperature greater than 100, okay, and the warnings is deleted, and here will show the error loading data because the temperature is greater than the normal area, greater than 100 degrees. So it will show error loading data. Okay, then let us see the humidity. Now humidity is 45%, and then if it's greater than 90, and then here is the warnings on the emulator, and then wait for 5 seconds. It will. There is also a warnings high humidity on the web page, and the data is the same. Okay, because the humidity is 0 to 100%, so it will not show the error loading data. Then let us see the status code. You see it's the normal static code is 200, and if there is a warning, and they will show the 500 static codes. Let us see it again. There's the warnings. And if we show it, change it to over 100, and here the static codes will become 500. Okay, here is the code and the exhibition. Okay, thank you for your watching.